So after writing this on the back, we're going to answer. Verify the segments with lengths of 3, 4, and 6 form a triangle. So I made your tests on Friday. You do have a question where it's not a triangle. So you need to make sure you're verifying and not just guessing that it's right. When we verify, what do? Add the two smaller ones. 3 plus 4 is 7. And then what does that tell me? Why is it a triangle? Yeah, because it's bigger than the biggest side. So 7 is larger than 6. So this is a triangle in general. So we're going to decide if it is acute, right, or obtuse. We're going to do that using the Pythagorean theorem. A squared plus b squared. And we're going to compare it to c squared. So the side that matters is c, which is the largest side. So which here is the largest side? 6. So 6 is c. So that means 3 squared and 4 squared. I don't know if you can really see the red. All right, so we figured these out. 3 squared is 9. 4 squared is. We're going to compare that to 6 squared, which is, okay. So what's 9 plus 16?
30, not 36.
Is 25. It's okay, it's Monday. All right, so here's what you need to do. A lot of people would say, well, 25 is less than 36, so it's acute. That is not correct. This represents the hypotenuse, right? The hypotenuse squared. It is larger. So because the hypotenuse squared is larger, what kind of triangle is this? Obtuse. Obtuse. Okay, and I wrote that at the bottom. If the hypotenuse squared is larger, so flip to the front. I am recording, just FYI. So, you're not going to write anything down yet. If you do, write it small, because I'm not yet actually at your notes. If you want to use, like, the bottom right corner, you can if you want. We're going to talk about triangles. In specific, this entire chapter is about trigonometry. Trigonometry. Do we know what trigonometry is? Study of triangles. Good. So we're studying about triangles. In specific, we're doing right triangle trigonometry, which means the study of right triangles. So these are highly important because everything in life has a right angle. I mean, not everything in life, but buildings, rectangles, a ton of things this will deal with. This chapter is the remainder of this quarter. So it's a lot. There's an entire class that Ms. Westcott teaches over trigonometry. If you plan on ever doing like calculus or business calculus, you need to know a little bit of trigonometry. So we're doing like the very foundation of it, very basic stuff, okay? So we're going to talk about a right triangle and the parts of a right triangle. One of them we already know. What is the side across from the right angle always labeled? The hypotenuse, okay? So we're going to be talking about a side called the opposite side and the adjacent side. So when you're talking about opposite, what wall is opposite of me? The back wall. What wall is opposite of you? The front wall. So when I say the opposite side, the question that you need to ask, the opposite of what? So what's going to happen is, pick an angle. Don't pick C. Sure, A. What side is directly opposite of angle A? Side A is the opposite. Does everyone see how it's the opposite? It's directly across. If you were walking into the room right here, A would be the opposite wall. So in this scenario, from angle A, side A is the opposite. Side C is the hypotenuse. So then what is the remaining side that will be called the adjacent side? What's the only side left? B would be called adjacent. Adjacent means next to, they share a wall. Like Miss Dix and I are adjacent. Miss Belk and I are adjacent. But if our perspective changed, pick the other angle. Angle B. From angle B, what side would be opposite of B? B. And then what side would become adjacent to B? A. Does everyone see how that changed? Will the hypotenuse ever change? No. Okay? So what's going to happen is, you see at the top you have SOHCAHTOA. This is called an acronym. Can anybody think of another acronym in real life? You use them all the time. OMG. That is one. I was saying in real life, like you text each other. Do you not text each other short things? That's what I'm saying. LOL. Like all that. So SOHCAHTOA is something we use to remember the 3 basic trig functions. Okay? You're going to write the words sine, cosine, and tangent. Sine, cosine, and tangent. Sine, cosine, and tangent. So on your calculators, we're not using them yet, but I'm just getting you familiar. On your calculator, sine will look like sin. But we are highly educated individuals, are we not? So we are not going to say sin. We are going to say sine. Okay? Still one syllable. It does not take any longer to say sine. On your calculator, cosine will say cos or cos. If you want to look like a dummy, you would say cos. If you want to look like a respected individual, you're going to say cosine. None of the above. Cosine. And then last, tangent looks like tan, but again, we say tangent. If you want to impress your Algebra 2 teacher someday, and if you go to college, your professor's there someday, you don't call it sin, you call it sine. Does that make sense? Sine, cosine, and tangent. Capiche? So what's going to happen is, there are how many parts to a triangle? 3 what? So we got 3 sides, A, B, and C. What else do we have? 3 angles. So how many parts are there to there are 6 parts to a triangle. 3 sides, 3 angles. So the purpose of this entire section is to find the missing lengths of all the sides and find the angles. Okay? So in order to do that, you need to learn about sine, cosine, and tangent. Okay? So our goal is later on. This is like the foundation, the easiest. Okay? So what's going to happen is, in order to set up a problem where we could find missing angles or missing sides, you need to know these trig ratios. I would write at the top, these are called trig ratios. These are called trig ratios. What is trig short for? Trigonometric, but yes. Trigonometric. Ratios. What does a ratio look like? A fraction. So you're going to make fractions, and these fractions we set up will help us solve for things later on. It'll make much more sense tomorrow or the next day. So on your quiz on Wednesday, you're finding trig ratios. This is what you're doing, okay? So I highly recommend sine, cosine, tangent, SOHCAHTOA, you memorize. So sine is equal to opposite over hypotenuse. So O stands for the opposite side. So I would write opposite. And H stands for the hypotenuse. So it's going to be opposite over hypotenuse. So sine is opposite over hypotenuse. Opposite over hypotenuse. Cosine is ca. So here is the one that most people get wrong. Not most. Boys get wrong. Because but listen, it's because some of you call each other ca. You know what I'm saying? So when people say SOHCAHTOA, they think, oh, ca is with an O. It's not. It's with an A. So think of the word so, if we say it a lot in conversation. So is with S-O, right? So ca is with an A. You just need to remember it's with an A, not an O. This is the one that people get wrong all the time. I'm just trying to help you. Ca. If you want to say SOHCAHTOA, you do you. So what does A stand for, you think? Adjacent. So you're going to take the adjacent side and you're going to write it over the hypotenuse. So adjacent over hypotenuse. Pretty sure it's how, I don't know, Canadian would say it. SOHCAHTOA. Eh. Tangent is toa, like boa. Most people think of boa constrictor. Does anybody know what a boa is?
Snake.
Okay, a snake, yes. But other than that, does anybody else know what a boa is? Yeah, it's like a feathery thing that women wear sometimes. Anyways, like a scarf. Anyway, so O stands for opposite, and A stands for adjacent. So it'll be opposite over adjacent. Okay, so SOHCAHTOA. Hopefully you've heard this before. It's taught since the beginning of time. Just kidding. It's been, I mean, I learned it when I was in high school, so it's been a while. We can ask. We're going to keep going. So we're going to do this problem. We're going to do two things with it. So it's a first triangle you're given. I would write off to the side. You're going to find the trig ratios from the smallest acute angle, and then in a minute you're going to find it from the largest acute angle. So I would actually draw. I'm recording. If you want to. If I were you, I would draw like a line and say we're going to find the trig ratios from the smallest. I would write the word from the smallest acute angle. And then in a minute, we're going to find it from the largest acute angle. It will make sense in a second. Acute angle. So your perspective matters. It's going to change what you call opposite and adjacent. That's why this is the way we're going to set it up. So we're using this triangle, this first triangle, and we're going to write the trig ratio, sine, cosine, and tangent from the largest acute angle and the smallest acute angle. We got people listening. Good. Okay. So we're going to do it from the smallest acute angle first. So the smallest acute angle will be across from the smallest side. So across from the smallest side. So what is the smallest side in this figure? 6. So what side is across from 6? Ooh, sorry. Go back. We don't have a name on this. All of them should be named. We should name this one. We're lame. You're lame.
R-E-N.
R-A-N.
R-E-N.
R-E-N. Are those your initials? Ren. Okay. R-E-N. Those are what we're using. Focus. R-E-N. You need to use capital letters because that's how we signify angles. Capital letters. So, we're going to go back to this. What is the smallest side? Still 6. So, you're interesting. 6 is the smallest side. So, what angle is across from 6? N. So, N is the smallest acute angle. So, this is where we're going to label from. So, from N, which side is the opposite side? Use the number 6. So, we got opposite. Which side is the adjacent? Sorry, we'll do this. Which side is the hypotenuse? That one's easy. 10. So that means which side is adjacent? 8. So here's what we're going to do. We're going to say sine, but we're going to use the abbreviation. So S-I-N, sine. You need to tell me from what angle. What is my perspective? From what angle? What was the name of the angle that we're starting at? N. So you're going to say N. Sine from N will be the opposite over the hypotenuse. So what is the length of the opposite? 6 over the hypotenuse, which is 10. Do we reduce in math? We do. So what is 6 over 10 reduced to? 3/5. That's all we're doing. That's it. We're going to move on to cosine. I'll explain why you're doing this in a minute and what this means. So cosine from what angle? N, the smallest acute angle. It's going to be from N as well. So cosine, so ca, this is the one everyone gets wrong. So it is adjacent over the hypotenuse. So what is the adjacent? 8, and the hypotenuse is 10. This reduces to 4/5. And then the last, we need tangent from the angle of N. So toa like boa. Tangent is opposite, which is 6 over the adjacent, which is 8. Reduce this down to 3/4.
So to solve it, you got to do all 3, or do you do that?
You have to do all 3. So when it says, so don't do anything. When it says find the trig ratios, there are technically 6, but in geometry we only do 3. Sine, cosine, and tangent. This is what it's looking for. This is what your quiz will look like. It'll say find the trig ratios from the smallest acute angle, and this is what you'll set up. Okay? We're going to do it from the largest acute angle also, because that's what we're going to do next. So the largest acute angle, I'm going to erase some things. Okay? What was this one called? N? I accidentally erased my angle. So your largest acute angle, is this an acute angle? No. It is a right angle. And a right angle is a right angle. It's 90, okay? You will never find sine, cosine, and tangent from a right angle. I need you to look up here and focus. You will never find sine, cosine, and tangent from this angle. Here is why. If you went to label your sides, what's the hypotenuse? 10. And what's the opposite? 10. That's not going to happen. You will never find it from the right angle, ever, ever. So what is the largest acute angle in this picture? It is E. It's also, this isn't acute, right? So these two are acute. They're less than 90. So we're going to find everything from E. So we need to relabel opposite, adjacent, and hypotenuse. Which one of these will not change? Opposite, adjacent, or hypotenuse? The hypotenuse is still 10. But now, Bryce, what's my opposite? 8. Which means 6 is now the adjacent. So your perspective matters. We're doing this for the largest acute angle. So hopefully you wrote like a line. Largest acute angle. So we're going to start with sine from what angle? E. So sine with a capital E. And it will equal the opposite over the hypotenuse, which is 8 over 10. And that reduces to 4/5. Then we're going to move to cosine of E, which is the adjacent over the hypotenuse. So the adjacent is? It is 6 over the hypotenuse, which is 10. 3/5, good. I ran out of room. I'm going to make myself more room. Tangent from E will be the opposite, which is 8 over the adjacent, which is 6. This reduces to 4/3. So here's what I need you to understand. So everyone put their pencil down and then look up here. I know we are circling fractions, but the whole thing is important. So when I say sine from angle E is equal to 4/5, this is actually an equation that we're going to be able to solve by the end of the week. What is the missing value? E. What does E represent? An angle. We're going to be solving, remember E, sine from angle E. We're going to be solving for an angle. It takes 2 buttons in your calculator. That's why setting this up is extremely important. Because if you don't set this up correctly, you're not going to be able to do this later on. That make sense? So whenever you do your quiz, which is on what day? Wednesday. You need to make sure you write the word, so sine, and then the angle you're coming from. If it's not there, I will automatically mark it wrong and not look any further. So what part do you absolutely have to have here? The capital letter, your angle, the angle you're coming from. Here's also a reason. Take out that scientific calculator. I don't know about the non-Casio, so just share a Casio if you have one. I just don't know about yours. Above the delete button, 2 rows above, it says the word sine, S-I-N, sin. If you clicked it, it says S-I-N and then a parenthesis, correct? That's because your calculator needs you to put in an angle measurement. So some people try on their quiz and they'll write sine equals 4/5. You look like a dummy, and this will be marked wrong. Super wrong. Okay? Because you have to have an angle. Either you have to name it that you don't know it, you name it the letter that it is, or you have to know the measurement of it. Does that make sense? So you absolutely need to have the letter, either N or E or whatever angle we're coming from. Okay? Again, if you don't have a Casio, I'll have to look at it and figure out how to help you. Okay? We're going to go back to our notes. We're just going to practice. SOHCAHTOA, that's all we're doing. Write the sine, cosine, and tangent ratios from angle C. So we're starting at angle C. We need to label all the sides. What's the hypotenuse? It is 50. The hypotenuse is always across from the right angle. What is the opposite? It's you don't know it. So do you have enough information to find the missing angle on a right triangle? Yes, you do. You use the Pythagorean theorem. We are going to solve for the missing side. That's the purpose of the Pythagorean theorem in this chapter. So off to the side, we're going to do a squared plus b squared equals c squared. Which one of these will represent c? 50. So that means I don't know a, and 48 can be b. Your calculator does this very quickly. 48 squared is?
2,500. Oh, you said 48 squared.
Yeah, it's okay. 50 squared is 2,500. I'm going to make this a little smaller. All right, so what's my next step to solve for the missing side? Subtract 2304. X squared equals 196. This is a perfect square. Take the square root, and x equals 14. So my missing side is 14. So let's go back to labeling our triangle. We have our hypotenuse. What is my opposite side? 14, and that means my adjacent is 48. So from here, we're going to do sine, cosine, and tangent. So sine from what angle? C. It will equal the opposite, which is 14, over the hypotenuse, which is 50. So we do reduce. 14 and 50 are both divisible by 2, so that makes 7 over 25. We'll move on to cosine from angle C. Cosine from angle C would be the adjacent, which is 48, over the hypotenuse, which is 50. All right, and then that reduces to, okay? And then last, tangent from C would be opposite, which is over the adjacent, which is, this reduces to 7 over 24. So I want you to be a good neighbor, and you're not typing anything to calculate. I want you to be a good neighbor and make sure the person next to you has the angle that they're coming from. So all of these should have a C. So make sure your neighbor is on track. We all doing good? Okay. One more time. So flip to the second page. Write the sine, cosine, and tangent ratios from angle A. In order to do that, what are we missing? A side. Yeah, it's not opposite. You're going to find it. So go ahead and find the missing side before we begin the problem. So you're finding the length of AB right now. Yes. What are you asking, Nathaniel?
What's up with your calculator, bro?
You could stop at the length. I mean, if you want to check yourself, you can work it if you want. No. So you were working by yourself, not with another person? Which one of these side lengths is C? 34, because it's across from the right angle. So 34. So that means we're going to have X and 30. What do we end up getting for X after we square, after we move stuff? X equals 16. Okay, so now we can label all of these sides. What angle are we coming from? A. So what side is opposite of A? 30. What side is hypotenuse? 34, which means the adjacent is 16. So remember, we're doing SOHCAHTOA. SOHCAHTOA. So we'll start with sine. Sine from what angle? A equals the opposite, which is 30 over the hypotenuse, which is, this reduces to 15 over 17. Cosine, so ca with an A. So the adjacent is 16, the hypotenuse is. All right, so we reduce this to 8 over 17. Last is tangent. So toa, so toa like boa, opposite over adjacent, which is 30 over 16. This reduces to 15 over 8. Good. So again, on your quiz, you're going to be asked to do exactly this. This is what your quiz is over. Okay? You'll need to be able to find a missing side also. So this is what your homework looks like. It will ask you specifically to find sine from angle A, sine from angle C, so on and so forth. So we're going to start with the first. So from angle A, we're going to label our sides. So Nate, which one is the hypotenuse? It is what? I didn't hear you. I didn't hear your answer. 30. So then what is the opposite, Nate? Opposite of angle A.
Opposite of angle A.
It is
Oh,
not.
my bad. Opposite, not adjacent. My bad.
And then that means the adjacent is 18. Good. So sine, so is opposite over hypotenuse. So that would be 24 over 30. What is this reduced to? They're both divisible by 6. 4 over 5. So that's all you're doing. Just the sine from angle A. Number 2, sine from angle C. So Bryce, which one is the hypotenuse? 40, good. What is the opposite? So what is directly across from angle C? So if you turned,
32.
thank you.
24. Yes.
Okay, so that means the adjacent is 24. Good. So we want opposite over hypotenuse, which is 32 over 40. What is this reduced to, y'all? 4/5. You're probably going to get tired of these numbers. What did I tell you was the most common Pythagorean triple? 3, 4, 5. So that's what you're seeing right here. 3, 4, 5. All right, next one, cosine. Who wants to do this one for me, labeling sides?
I do.
You already did one. Paris, can you, we're coming from angle C. So what's my hypotenuse, Paris? My hypotenuse?
25.
My opposite is?
15.
Okay, which means my adjacent 20. What do we need for cosine? What goes in the top of the fraction? Adjacent. So 20 over 25, which reduces to, I promise not all of them are 4/5, but just right now. Yes, dear.
Oh, my bad.
Okay. Caleb, can you help me with the last one? Ah. I almost fell. Sorry. The opposite, yes, it is 40. So sorry, Brady. Yep. Good. All right, so my fraction is going to look like 9 over 41. Can that be reduced? Yeah. 41. You're going to go to the back and draw these two. Writing both of these down on the back. You're drawing this triangle, finding tangent of C. And then this is what some of your homework looks like. So that's what we're going to talk about. So hurry up so we can have time. Come on, move. Y'all are taking the longest. It's really because of that. No, we're trying to get stuff done. All right, so in the first question, we're finding tangent of C. So from C, we're going to label our sides. What's the hypotenuse, y'all? 34. What's the opposite? That means the adjacent is. All right, so opposite over adjacent. So that'd be 30 over, what do you say? 16. What is this reduced to? 15 over 8. Ta-da.
3 over.
15 over x. All right. Last thing. Use the calculator to find the value of each to the nearest thousandth. So first, we're going to talk about rounding because apparently that is a struggle. What if I said round to the 10th? How many decimal places is that?
1.
It's 1 because how many zeros does a 10 have? 1. If I say round to the 100th,
2.
that's 2 because how many zeros does 100 have? 2. So I'm saying round to the nearest thousandth here. How many zeros does 1,000 have? 3. So this is 3 decimal places. So again, if you don't have a Casio, I can look at yours and make sure you're doing it right. You're going to take your calculator. Well, before we do, I'm going to explain this. So before, when we say tangent, so focus on what we're doing right now. Don't touch your calculator. Tangent from angle C equals 15 over 8. I told you this is an equation that you could type in to solve for something. What is missing in this equation? C, angle C. So you're missing an angle, and you're given a trig ratio. Does everyone see what we're talking about? Trig ratio is a fraction using sine, cosine, and tangent. Are we all okay with this? Okay, so this problem, you have sine of 36. So what are we given in this one? We're given an angle. So when we type it in, what do we think it's going to give us? Missing what? Trig ratio. Yeah, it's going to give us not a fraction. It's going to give us a decimal. Remember, a fraction is the same thing as a decimal, right? We okay with that? So you're going to take your calculator, hit the sign button. It'll open a parenthesis. You're going to type in 36. You don't really have to close the parenthesis here. You can if you want to. But since it's the only thing you're typing in, you don't need it. You're going to hit enter. That's it. Sine of 36, enter. If you don't get the same answer that I do, then you need to tell me because you're in the wrong mode. Okay? So don't just say, well, I have no idea how she did that. It's fine. You're going to not do well the rest of the chapter if you're in the wrong mode. So we're going to practice rounding. I want to round 3 decimal places. You're going to tell me 4 so we can decide how to round. Okay, so what does it say? 0.5, 877. So we want to round to the 3rd place. You look at the number behind it. Is this 7 going to make the 7 round up or down?
Yes.
Up. Not that you round down ever. So you can have 0.588. If you don't have that number, you need to flag me so I can fix it on your calculator. Okay? This is the end of the lesson. I'm going to tell you about your homework. If you don't have a scientific calculator, here are some options. You can do the part that required a scientific calculator first on the back. Or, if you don't have one, there's this thing it's amazing. It's called Google. If you Google scientific calculator, it's going to pull one up for you. And you just use it like a regular calculator. Do we understand each other? Okay. So I'm going to give you your homework. Those are your options. Did anybody not get the answer that I got? Everyone got it? 0.58? Okay, I'll look at it. Okay, I'll look at it. 5, 6.
Yes, sir.